Good evening, and thank you all for joining us today. My name is Rashmita, and I'm the event planner for Microsoft Reactor Bengaluru, India. This session will run over the next 60 minutes, including Q&A. The session is being recorded and will be uploaded to our Reactor YouTube channel. I will share the link to our YouTube channel in the chat section soon. Before we begin, please take a moment to read our code of conduct. We are all here to learn together, so please be respectful of other people's views, understanding of differences, being kind and considerate in the way you engage. The chat will be open throughout, and we do encourage you all to participate. Also, please keep your mics muted during the session. I would now like to welcome Shivam, our speaker for today's session. Shivam is an author, cloud architect, speaker, and co-founder at TechScalable. He is passionate about technology and works on Azure, GCP, machine learning, and blockchain. He is also a Microsoft certified trainer. But for now, I will hand over to Shivam to begin the session. Over to you, Shivam.
Thank you. Thank you, Rashmita. Sorry. Thank you. Let me just quickly share my screen. Okay, so let's get started. And I will just quickly walk you through the agenda as such, and then we will have a look at the topics which we are going to cover today. So I'll just show you the learning objectives over here.
Shivam,
Okay.
1 minute before you just start. Shubhash, I see you have raised your hand. If you have any question, please use the chat box and drop your question. Shivam will take questions in between. Right now, I have disabled the mic for everyone. And once, Shivam is open, I will enable the mic again for Q&A round. Thank you. Over to you, Shivam.
Okay. Thank you. Okay. So good evening, everyone. Hopefully, all of you are safe. You're doing well at home. And today we will be going through the PyTorch basics and the PyTorch building or the concepts which will help you build your knowledge if you are working with PyTorch and Azure Machine Learning Service itself. So this is part of the series of sessions which we are doing, where few days back we had this session where we were using the visual designer of Azure Machine Learning Service to get started with the machine learning jobs. And then today we are thinking of how can we create custom AI solutions with the use of a very popular framework called as PyTorch, right? Now, if uh, if I can just quickly show a couple of things to you. So this is the learn module which we can follow after the session itself. And this is the one where everything which we are covering is explained in a very structured manner with examples, with videos which are embedded over there. So today we are starting with the introduction to PyTorch. Next week we have another session on custom vision with PyTorch, where we will be working with more complicated architectures as such. So whatever we will learn today will carry forward in the other sessions also. So we will understand that what's the meaning of a data set, data loader. How do you basically create the layers, your deep learning networks layers with PyTorch? How do you pass the input data through those layers? What is the meaning of optimization as such? Where will the uh, differentiation will come in which particular step? What is the loss function? How do you pass it? The entire skeleton structure of any PyTorch specific model. Now, if you look at this learn module over here, so it's basically starts from what are tensors, and very nicely it explains what are tensors, and you don't even need to have Azure subscription to run this. It's They provide sandbox environment over there where you can simply click on that and log in with your Outlook email ID and basically do the step by step tutorial as such. Now, just want to show you a couple of things and then we will just go back to what we have. So basically, to be able to understand or to be able to work with any framework like TensorFlow or PyTorch, the journey starts from what is Tensor itself. So today also we will see what is Tensor. We will see what are the various type of tensors which are there, what is the logic behind it, how do they look like, and so on and so forth. Why do I need them? If I am ingesting any image, then how does it basically translate into a tensor, and then what do we do with it, right? All those things. So they have here in this module, we have a pretty intensive deep dive into all the operations. We may not be doing all the operations today, but this is something which you can also go into and try all the possibilities with, or all the possible operations which are possible on tensors. Now, after that, if I just show you a couple of other modules and then we'll just get started. So how do you load data in, so what is this PyTorch dataset and what is this data loader, right? Dataset is the one which is holding your data and the labels. Data loader is the iterator around that. It wraps the iterator around that, and then the batches we can load the data or we can read the data in batches. We'll see that. Okay, how do you transform your data? What are the various things which may happen there? How do you build your models layer, right? So when you have to define that neural network, then how will that initial skeleton will look like? In which function? How do I define the layers, and then how do I do the forward pass, and then how do I do the backward pass? So those things are over here. Can I do something like automatic differentiation? So how can I optimize the entire loop itself, the loop which we have? How can we save and then the full model building process and summary? So this is something which I recommend that you bookmark that. It's available in the on the landing page over here, and go through this, try this out, and it doesn't require any subscription to be tried as such. Okay, now, so let's come back and okay, so let's get started. So basically, I'll just quickly revise, or we will just quickly recall, or we will just quickly go through a couple of basics around the Azure Machine Learning Service. And these are the things which we were discussing in the previous session as such. So we'll just start from that landing point, and then we will just jump into the custom AI part. So I'll take a few minutes of your time to just quickly put things into perspective. Now, notice this over here. So whenever you are working with Azure Machine Learning Service, basically we have different locations which can be connected or which can be registered as a data store inside the machine learning service. These locations are literally the data, are the locations where data is stored in Azure. For example, data lakes, storage accounts, uh, SQL databases, Postgres, MySQL. So we can register them. So it helps in the connection configuration. We don't have to pass all the connection strings, and we will call that as data store. Then, then on top of it, we have the data sets. Data sets are the metadata. We have tabular, we have file data set. Tabular is when we want to load something in a pandas table, and file data set is when you want to iterate over multiple files which are lying in your maybe data store. So you would like to run some loop and load all the data from there. Then we can work with the file data set. This is more like a path from where I can go and further read things. Okay. Then after that, we have the compute clusters. Compute clusters are the ones where training happens, like where you submit your job, or the job has to be written somehow, right? Somewhere it has to be written. So we can use the designer to write the job, or to basically drag and drop and create the model in a code-free mechanism. We can also use the compute instances. Compute instances are the development environment where all the popular machine learning and data science packages will be pre-installed. Further, you can install whatever you need in that point in time. And this is your development environment from where you will be able to do the experimentation. And this machine is a VM. It runs in the Azure cloud. So the data of the company is there inside their Azure environment. It's not anywhere on-prem like that. Okay, now from the data, I mean that the maybe the notebooks, or maybe there is a sample of the data which the data scientist has locally copied on the machine for some local you can say experimentation before submitting the job to production. So that data also has to be we have to make sure that it is also secure in some location. Now the next thing is that we can also connect Databricks. You see this red thing? I think I didn't name it, but you see this red box over here. This is the Spark cluster. So Databricks is also available. This is called as attached compute. So you can submit the job into Databricks and your Spark engine will execute that job, and then you will get the trained model which you can save later on. So this is that particular module over there. The trained models, once the models are trained, we definitely would like to have a location where we can save it. So this we have the model registry already inside the machine learning service in Azure, where you can version it, you can save it, you can put descriptions on it, you can put tags on it. So you can recall later on after maybe a month that which algorithm was used to train this model, what was the learning rate used to train this model, and what were the hyperparameters which we defined to train this model. So that type of description or tags or metadata can be added along with the models as such, and it's part of the solution. It's registers there. What else can I do with it? We can create the AutoML pipelines. So in future sessions we will do more about AutoML pipelines, but basically AutoML is like you specify the family of the algorithm, you specify if you would like to do any specific type of transformation or avoid any specific type of transformation, and let the platform take care of it for you. And you can in the meantime go and have a coffee maybe, and the time you are back, your model or multiple models may have been trained, and then we can further uh, filter out the algorithms we would like to further evaluate. So that is also possible in Azure Machine Learning Service. We also have the options to deploy things directly from there. This is not something uh, which may be the main feature of machine learning service, because directly deploying in a Kubernetes cluster by right click may not be the most appropriate method to do it, but it is possible. So the reason we have it over here is because when you will create your MLOps pipeline, then in that MLOps pipeline, which I can see over here as this blue pipeline, that's how I have put it over there. That MLOps pipeline is the one basically which will be uh, sort of integrating the solution with Azure DevOps tools or any other tool which you have to do the deployments, to do the CI and the CD, the delivery and the deployments as such, or the entire model management, uh, registering the model if the new model is outperforming the previous model, running the test on top of it, and so on and so forth. Okay, now apart from that, we have endpoints option. You can do API calls once things are deployed. We have data drift monitor in Azure Machine Learning Service, which basically finds that which basically let you know that things are going wrong in production. Uh, and before people can start complaining, you will get an idea that the model's performance is degrading. And once we come to know that, we will be able to retrain the model, or at least we'll be able to understand why the model's performance is degrading. Maybe the patterns are changed. Maybe the data which is coming for scoring in production is different from what you trained your ML model on. Or maybe there is a new data set which is available now in your sources, which recently got published there or put there by another system, and maybe we have not used it. And that particular data is having new patterns as such, the spread is different, the distribution is different over there. So those type of things can be taken care by the data drift monitor. Okay, so let's go to Azure now. Okay, the very first thing, what are tensors, right? So we'll hit with PyTorch. So let me see if I can just quickly start from that. Okay, now I'll just take you directly uh, into my Azure Machine Learning Service. I have deployed this service. It is running over here. I have couple of I have the compute cluster also there. I have compute instance also there. Compute instance is the development environment. Cluster is the one where we submit the training job. So this is my compute instance. I will just open Jupyter notebook over there. We can work with this option as well over here. You can just make the notebook and work in the inside the ML Studio. This is the Jupyter notebook, which is opening up right now like this. Okay, so okay, let's get started. So now I will just slowly zoom in over here and I'll explain what we are doing and what are the various components which you should be aware of when you're working with PyTorch and what are the basics of PyTorch. And this is something which is applicable on any other whenever you work in future, all of this will be like the boilerplate code which will be there apart from any other thing which you may require. Okay, the very first thing is what are these tensors? So the tensors are defined as the you can say n-dimensional arrays as such. So we have different ranks of tensor. If I say rank 0, it's basically a scalar, one single value. If when we have rank 1 tensor, we define it like there is a line and these are points on the line. So you will be able to find any particular value in this array by just providing one value. Rank 2 tensor is more like the points on a surface over there. So this is the metric where we have the some m cross n metric is there, and you may have to provide two values to find your data. Now, this is what we are using today because we are working with images, and we'll have uh, rank 3 tensors, and some of the intermediate output which will be getting generated will be having even more rank beyond that as well. So that is also possible. So there are tensors which are even possible beyond 3. So you can look up it in any of your favorite search browser. Now, basically, this is what we are going to work with. And to understand the tensor, basically, you can say that this is when we have the points on a cube. And and in our scenario, these are just images which we are working with. Now, I'll just show you the data. I will quickly uh, show you something. And okay, so it's a very popular data set called as MNIST. And we have another variation of that called as Fashion MNIST. So this is what we are using for understanding the basics of PyTorch. Now there are 60,000 images in the training dataset, and around 10,000 images are there in the test dataset as such. And so we will be training the model with 60,000 images and testing will be done with 10,000 as such. Uh, 10 classes are there. 28 by 28 pixel images are present, right? So this is the dataset. That's how it looks like. You have t-shirts, you have dresses, and sandals are there, pullovers are there, and so on and so forth. Coat, t-shirt, and other things as such. Now, the very first thing is we literally have these pictures with us, right? Now, we to be able to work with these pictures, the first thing which we are going to do is we have to flatten them. So I'll just try to put it somewhere here, right? Okay. Now we'll start developing it on the way, but just to put few things before we do that. So so imagine this is one of the picture over there. So this is one of them. Okay. So this is one of those, and this is maybe how it is looking like, right? Like this. So this is 28 by 28. Okay. So we will be putting one flattened layer and we will convert this 28 by 28 input image into we will convert that into an array which is having 784 units or pixels over there as such. That's one of the initial thing which we are thinking of, like this. And if I can create a straight line, that will be uh, pretty good. Okay. Now, once we have this, behind that we will put more layers, right? I will show you the further layers, but just to briefly put things ahead, we will have the linear layers over there, and we are going to put three of them as such, like this, behind that, right? And we have 10 classes, so we are doing a classification right now, and we would like to see which input picture is what of what class as such. Is it a t-shirt and so on and so forth, all those things. So the output will be finally having 10 units over there, or the output is going to have 10 classes. So this is what we are starting with. Okay, so check this out. Now the very first thing which we have to do is we have to load the data. And it will be great if we can have some sort of mechanism by which we will be able to iterate over the data. And when we are working with deep learning models, we would like to ingest the data in batches. So we want to have some sort of iterator which can provide us with those batches. And we are going to define those, like the batch size over there, like how what's the batch size as such. Now, if I just get started with it, the very first thing is that let's start with let's say if we have to visualize something, so we would like to invoke matplotlib inline as such to create uh, any we want to see the output, or we want to display a few pictures and so on and so forth. So that's basically we will try to go for that. Okay, now now when we work with PyTorch, there are two ways, or there are two primitive ways, or two simple ways by which we get started. First thing is we create, let me just see if I can put the markdown. Okay. Now, the very first thing is we have dataset. Dataset will have your data and the labels as such, right? Second thing is called as a data loader. Data loader is will wrap the dataset and will provide that iterator which we will be able to iterate over and get the data in micro batches like that, or in according to you, the batch size which you have defined as such. So these two things are what we need to get started with. Now, when we work with the data set, these PyTorch data sets are, there are sample data sets also which are available. Fashion MNIST is one of the sample data set which is already available there. If I want to have my own custom data set over there, I just need to provide the location where the file is present in that point in time. And the data loader will be wrapping that up. Okay, so let's get started. We have to import a couple of things first to be able to, oh, let me see if I can type in the correct location. Okay, so we have to import PyTorch. Now let me just check the kernel. Okay, so PyTorch should be already installed there in this kernel over here. Otherwise you can install it yourself. Now, can I use any other mechanism, my laptop and so on and so forth? Everything is possible. It's up to you. Basically, use any way in which you would like to work with. So PyTorch provide these classes which are like the NN dot module which we will be using in our example, and all the layers we talked about, flatten, linear layers, activation functions, everything, those layers are defined over there. We would like to use that. Now, we would also like to get the data loader and the data set. So they are part of the torch.utils and data from the, uh, let's get the data loader. And we will also would like to get the torch, the data set, which is part of, I am going for the MNIST fashion data, which is part of the vision data. So torch vision, and just import datasets. Now today we are just developing a very small example, right? It will just have maybe 20 line of code, not much. But this, whatever we are doing, will further translate into other sessions which we are coming with in uh, next week and so on and so forth. Okay, now apart from that, I'm working with pictures. I would like to convert those pictures uh, into tensors. So I have to get that the you can say I have to get the two tensor, so it can convert into some sort of tensor. And if we are doing any type of transformation, we can use the lambda, and maybe we have to compose a couple of things on the way. Now, okay, so matplot and okay, plt. Let me check if everything is fine or any typo. Okay, so let's change that, and it is basically import. Now, okay, so now we have to define the data set. This is where this is the one which is going to hold our data and the labels as such. We are using the one which is provided by PyTorch. We can also have our custom data set using the same logic. You just have to specify the path over there. So let's download the data for training the model right now. Okay, so and so let's call this as training data, and let's get it from datasets, and the name is fashion amnist, and we have to specify like if it is not locally available, then we have to download that. So we have to specify like maybe the download location, or you have to specify that what's the purpose of it. Like, do I want to get the 60,000 images for the purpose of training, or do I want the 10,000 images for the purpose of testing as such? So, and if it is not available, then just download it and just put it in the root of location there, and we will work with it. And please do one more transformation for me. So I can put transform here and transform to tensor. Just give me 1 second. Let me just quickly sip some water. So as some of you may be aware of that, I am sort of still recovering from COVID. It's been many months, but the after effects of COVID is more, you can say it's pretty long. So I'll just quickly sip some water. Give me a second. Okay, check this out. Now, so we are getting the training data over here, and it will be there in the root. We are going to use this for training purpose. So training true, download will be true, download from internet if we don't have it, and so on and so forth. So, right. Now, similarly, we also have to download the test data. Okay, so let's do that. Let's download. So we'll use another data set to store the test data. Okay, now same thing. And let's do this. Okay, same fashion amnest. Let's put it like that. And the syntax will remain same or similar, apart from like what is the purpose of this? Do I have to download it, or do I have to test with it, or what's the purpose of it? So we are not, this is the test one. So we'll say we don't want the test one. Give us the 10,000 test images. We don't want the 60,000 train images. That's not what we are looking for. So download will be true. If we don't have it, we would like to get it first. And then same thing, transform and to tensor. To tensor is just one of the way in which you can create new tensor. To find all the methods, I will recommend that go have a look at the uh, notebook which we have shared as part of the session, right? Now, okay, so we got the data, but this is a data set. I would like to have something which can automate my iterations. If I can define a batch size, something should be there like a wrapper which can iterate over this and get me my batches from there. So we have the second, you can say, so the second way in which you work with PyTorch will be by creating that data loader. So the data set which we have just defined will be the input of the data loader. So this is a data set. This goes in the data loader like that, right? That's the sequence which we'll be following as such. Now we need the batch size first. So we will start with 64 images in the batch size as such. Now we will create the data loader. So create the data loader. Okay, we need two of them, one for training, one for test during the test time. So we have to create two of them and just put it up something like that. And this is a data loader which will be working on the training data. Okay, so like this, and we have to specify the batch size. So it needs to know what is the batch size, which we have just defined as the batch size itself. So we will just say batch size equal to batch size. Okay. Now we need one for test purpose. So data loader for test, and then this is going to be the similar to that we have. Uh, this is also train. Okay, so let's make it as test, right? This let's make it as test. Notice that. Okay, so anyways, uh, okay, so let's put it as testing, and this is going to be data. I'll look for typos later on. When the errors come, we'll just check it out. Now, the batch size is required. So batch size will be batch size. And let's give that batch size over there. Okay, now, mm, okay. So what will happen in this step? The what is the so like 64 pictures or 64 is the batch size, which we will be using to train our model. And these batches will be read from that 60,000 images which we have. Now we have this in place. Let's go and think in terms of the model which we have to create. So we have to now, if you are creating any neural network, you have to define the layers which are there. And once you have the layers with you, the second thing which you want is how is the data passing through that layers? What is your sequence as such? Like, do you want to first flatten the data? Then next will be some another layer as such, right? And then what's the return on top of it? So we have to define so we basically have to create the class which is having, let's say we'll create a class neural network, and it will be inheriting the PyTorch main nn dot module, and we will use whatever is there in nn dot module to get that layers and the functions and so on and so forth, which are part of the parent. So we will do that. Now, one thing which is very important from deep learning's point of view is we are not going very deep today in the deep learning's point of view. Like, we don't have many layers, neither do we have enough number of parameters to be overloading something or hitting any upper limits and so on and so forth. But if you think it through, if you have GPUs, it is great that if you can use GPUs, that will be great. And GPUs will definitely, and one of the amazing thing about the tensors which we have in PyTorch is that it works with GPUs. So uh, I would like to use GPU if I have it. If I don't have it, then it will just use CPU. So we are just defining that if it is available, then use it. If not, then okay. So and okay, else just use CPU. So this machine right now is CPU. This doesn't have GPU right now, so it will basically will not have it. Okay, so Okay, now we have to define the model, right? The main thing. So let's do that. Now, when we define the model will have this class will have two functions. First function will be define the model as such. Okay. The first function the uh, will be the one the init itself, which will have the definition of your layers, like what are the various layers which we have. Second one will have the will be the forward, like it will let us know how to pass the input data through that layer. So if I define that, so and we are going to inherit the PyTorch nn dot module parent as such. So let's go ahead. Let's get started. So we'll call it something neural network. So maybe we should call it simple neural network or something, but or maybe not very deep today. But we will be using everything which we are doing here in the we have sessions coming for on computer vision, on NLP, uh, and we have many more things over there. Okay, so let me just quickly. Okay, now. mm, okay, so we would like to use all the things which are there in the parent. So let's do that. We'll use self. And the first layer which we would like to work with is the flatten, because we have 28 by 28 pixel size is the image size, 28 by 28 pixel, and that itself we have to flatten first to be able to work with. Oh, sorry, I clicked something. Okay, uh, now so we are just going to use the flatten over there, and this is where we have to, maybe you can say, know how many uh, let's say how many the size of the number of neurons which will be there. So that will be 784. We'll print it out. We'll see in the print section how it looks like. Now, so after this, we will be using one. We want linear layers as such, and we are looking for multiple linear layers. And the activation function which we are using today is the ReLU activation function, and which is a very good starting point. And we would like to use the sequential method. So there is a sequential layer which we would like to define now. So that, and now the okay. So how what are the layers we are going to put? Let's say nn dot linear, and we have to specify the input and the output size. Otherwise, sort of we'll start getting some issues. So this is the input image size which we are getting from the flatten. Flatten will be giving the 784. It will be having 784 units over there. Now, what is the output size of it? There is a lot of you can say theory behind what is the most optimal number of layers. How many what is my number of layers should I have? What type of which one should we not use? What we should use? What we uh, what maybe let's say when to do dropouts? How soon to do dropouts? Should it be let's say on which layer should it be, and so on and so forth. So all of those theories there as well, and we will just go with this, and let's put another activation function here. So this will provide that, because these linear layers are just going to do some linear multiplications. So we would like to get the non uh, you can say non linearity over there with ReLU. Okay, now we'll be going with another one. And finally, if we remember correctly, we have 10 output classes. So we have to do that. That input will be 512, and the output is going to be 10 classes as such. And then on that 10 classes, so that's the output as such. Now we will like to define the other one as well, the forward. So let's do it. So forward basically means that how is my data going to be passed. I have the skeleton of the layers, but how is the data passing from it? This is what we define in the forward function over here. So we would like the data to be first, you can say, maybe going through the flatten, and once it has passed through it, why don't you go into the, you can say, into the linear layers which we have in sequence over there. So we would like to use that, and let's use that. And then what are you going to return? So I would like to return the the output which is going to come over there. Okay, so now we will just create the instance of it, and just give me 1 second. Okay, so if you have any questions, put in the chat window. I have the chat window open in my secondary screen. I will take the questions on the way. So basically, we'll create the model now. We will just create the instance of it, and we have it called as neural network. And we would like this neural network to be working with GPU if we have it. So we have defined that as part of device, and otherwise it's gonna use CPU. So let me quickly check if everything is fine. So let's print the structure of the model. Okay, so we'll just basically go and see where have I done what. Okay, so mm, let me just go and quickly correct that. Okay, so this is something not right here. Okay, that's one thing which is missing. Okay, let's try. Okay, next will be rel is not defined. So let me define that, and let me quickly try to do that. Okay, so let me check it out. Okay, I'll do the, let's try this out. Okay, great. So we have 784 in the first layer. 784 is the input features, 512 output, then 512, 512, 512, finally 10 is the final output itself. Now, just like we learned something, the models also, these deep learning models or these neural networks also make mistakes. So we have to first find the offset, like how bad are they doing, right? And based on that, we have to make the changes in the parameters. So we would like to first understand the loss which is going to happen, or you can say that what is the size of the offset which they have from the accurate correct values. So I would like to use the loss functions over there. So I'm defining it. This is also required for you to be working with uh, uh, PyTorch. Now there are many loss functions. We are going with cross entropy, and basically let's just go with it. Learning rate. Now, learning rate is going to help us in understanding when the model, when the weights are changing, how big a change can be done. So it will have a lot of impact in the way the model is training. So this basically means 0.001 like that. So now when the offset is there, when there is my model is performing bad, and I would like to basically uh, would like to change the weights, then should I, what is the gradient of it? Should I, how much should I change? In which direction should I change? Should I add something, remove something, and so on and so forth? All of that is going to be part of the optimization phase as such. Now we have various type of optimizers which can be used. We are using the one which is called as stochastic gradient descent over here. There is a lot of background behind that as well, and maybe one day we might be seeing the mathematics behind it, right? So but I will be just using it right now to use it on my model parameters. And on those model parameters, I would like to be working in accordance to the learning rate. So let's do that over here. Now, okay. Now we have to. So now we have just two more cells to go to. Now we would like to start the model training. Now there are two things which are going to happen. We have to train the model and we have to test the model. So we are defining two functions now, and the first function is the training one, which we will be calling later on, and the other one will be the testing one, which will be calling in the same cycle later on. So two of them we are defining over here. Now anything can be there inside these functions, and the skeleton is what we are working with right now. Okay, check this out. So let's do the first one, and we'll call it as maybe the train one. And we have to pass the, now what are we supposed to pass? We are supposed to pass the data loader uh, over there. Which data loader? In the training part, we will further pass the training data loader, which we have created earlier, called as training underscore uh, something something over there. We'll go and have a look at this. So that will be passed. Secondly, the model is the next thing. What is my loss function? Which one I'm using? That needs to be there. And which optimizer are we using? That also needs to be used over there. And then basically we would like to know the batch, the size of the batch as well. So we will do something like length on the data loader data set, and which we will be passing later on, which we have already defined. So data loader dot data set, and then on top of it, because we are working in batches, so we have to do a couple of things with the batches, and my labels will be, I need to iterate over them. So we will do that over the data loader, and that data loader is the, sorry, okay, the data loader is going to be the one which we would like to be working with. But let's see if we have GPU. uh, we will just define the same thing, tensors. If you can go to the GPU, or so the good thing is, in this compute instance, I don't have GPU with me, but in my compute cluster, I do have it. So whatever we define over here will also be, we can do the remote submit, and then the model will be trained. And we do have to make few changes here and there about the how do we start the experiment, how do we start this experiment session, how do we have to start the logging as well. So there are a couple of more things which will go in some locations, but definitely we can submit this file as a training script to the compute clusters where the remote training will happen. Okay, so we have to do the model dot predict over here. So let's do that. And once the model dot predict has been done, we would like to understand the loss which is going to happen, uh, how much, what's the offset between the truth and the predicted value. So let's do that. And then the back propagation will come into picture. So we have that optimizer already created, and we would like to use that optimizer to help us do a couple of things. Now, there is one thing which happens in PyTorch is, by default, PyTorch is sort of designed, you can say, not really designed, but I'll just show it to you. So let me say optimizer 0 grad. So if I don't do this, then what will happen is like the previous gradient values will get added up, and that is useful for reinforcement learning. But we are not doing reinforcement learning right now, so we would like to we don't want any value to be added up from the previous loop or cycle or like that. Now the optimizer, we would like the optimizer to be working with it. And okay, what will happen when the batch will not have any more data? So if, let's say, if the output is basically 0, Then we would like to print out that how has it performed, good, what is the average loss, and any details about the maybe how many loops are going on or things like that. So we will just basically would like to print out a couple of things, and let me just put it up. And okay, so we are going to say that the loss is this much value, and we can also do some sort of string formatting on it, so it looks a little floating values, but slightly uh, more structured as such or not. So let's see if we can do some more things with the uh, with more outputs over there. So if we have integers, I would like it to be formatted some manner before putting it out over there. So let's do a uh, okay. Now, mm, let me see. So basically, this is a training part, and let me just quickly check it once. So we had defined the data loader model, the loss optimizer, and the length of the data set. And for each batch, let's send the devices, do the model predictions, find the losses over there, start with the back propagation over there, and let's make everything as 0. Then let's do the backward pass and use the optimizer during that. And if the batch is basically not having any data left, then start throwing some outputs. So we can know, is it working out or not. We don't want to run unnecessarily if it's not, you can say, if the loss is not coming down, if the accuracy is not going up, then we can simply look for another approach to be uh, to be applied, or we can think of what else can be done over there uh, in that particular scenario. Now looks better. Now let's quickly create one more, and this is for the purpose of test over there. So logic more or less remains same. We need the data loader to be given over there, and then we also would like to have the trained model. And let me do that. Now the size of the testing data set is going to be 10,000. So let's do something with it. And okay, so there is a particular thing called as eval mode. So which will you can say which will tell PyTorch that we are doing model evaluation. So it is that's what we are looking for. And let's put no values first. Let's define everything to be 0. And now we have the option in PyTorch to be doing the auto differentiation, but that can be further done over here. We'll see it in the other sessions. When we are literally going into a lot of layers, we will be using it. And if you would like to know more about it, the link which is there as part of the uh, session is what you can go for. Now, let's see if we can send this to the devices, and let's put it there. Okay, I can see there is some question in the chat. I will see if I can just maybe have a look at that. Okay, now the link will be there in YouTube, and whatever we are doing is part of the learn module. So the learn module I will just put in the chat window. It's available on the landing page. So it's going in the chat now. Those who would like to do this, you can simply log in over there, and do it later on also. So we are just finishing a part of it. There are a lot more details which you would like to see in more, you can say, you may need little more time for that. You can do all those things. Okay, let's wind this up, and we will see a couple of more things over there. Now, now I would like to uh, understand the loss which is going to happen during the. We would like to understand how is it performing on the test data, and let's get the information from the dictionary. Okay, so and what were the ground truths maybe? Okay, now. mm, okay, so if this is correct, model might be doing things correctly as well. So then what may happen? I'm just gonna quickly put few things over there and sum it up and okay, something like that. Okay, let's find the average. So we would like to understand that what is the average test loss and the what is the average of the average loss which is going to happen over there. So we would like to go for it. So I will just going to do that, and we are just about to just run this, and this should be something to do with the batch size and the the size of the batch, and we will just see if we can just print it out and maybe make it slightly look good. So the test errors are going to be having let's go to the new line, and let's say accuracy is going to be the will be so let's say multiply by 100. So let's put the percentage as such over there, and let's go something like this. Okay, correct values, and whatever we are going to print out, let's format the float operators there. Let's format uh, the output as such, and then what is the average loss uh, which will be then something to do with uh, whether it is reducing or not. We will be able to get a more idea of what in which directions can we further do few optimizations. So let's go through this. So we have the test data loader here, and we will be just finding the size of it. We are running this in evaluation mode, and we don't want any automated differentiation to happen. We would like to send everything to devices, and let's do the prediction with the model and calculate the test losses over there, and let's find the correct predictions as well. So dot type, okay, some okay, and then the test losses on top of it, and then print it out. Okay, so let's see, and I will just have a look at the statement which I have written over here. Okay. Now done. So we just have to call both of them, and this is where we have the epochs, and you can define your epochs. I am putting 5. I have 1 minute left of my session which is defined for me, but I would like to run this quickly. So definitely epoch, you can work further with it, and I would like to see if I can have at least one of them or 5 of them. Okay, so and during the epochs, it will be great if we can uh, have some sort of let's say number over there, which epoch is going on, and then we would like to uh, work with it. Okay, now we just have to call both the functions which we have created, the train and the test one. And in that train, we are passing the train data loader. So I think this is the name which we have given, and the model is already defined earlier, and the loss function is already defined as well, and optimizer is also defined uh, earlier. And in the testing loop, we have the data loader of test test underscore data loader, and test underscore data loader is what we have defined. Okay, now and the model which will be there, and if and then just maybe print something that we have finished the epoch maybe, right? So okay, so let's run this and let's see if everything is in place, or do we have to go and make few changes here and there. Okay, okay, let's try it out. So okay, now the epochs are starting like this, and I have executed this couple of times. The maximum accuracy which it will finally go to is 70, like that, uh, over there with 15 epochs as such. So it will slowly go up as such. Now you can further, what can we do with it? We can have different ways to handle the image, which the image data which we have. If we have convolutional neural networks, they will just outperform this simple network which we have created with couple of linear layers over here. And if we take care of our hyperparameters, and if we work with more on the tuning part itself, the learning rates even, we will be able to make a lot of differences in the model's performance. Max, it will go till 70, like that, 70 or 71 something. Okay, so now what is the next step for us uh, to take at this point in time is the link is available over here. If you go to that, you will find that whatever we have done is also there, and there are way more details which Microsoft has have defined over here as part of various details. If I click on one of them, they have these notebooks embedded there. So how to do the hardware device for training, get the hardware device, what is that neural network class which we have created, uh, what are the details, what is flatten, what is model layers, uh, details about it. If I click on this, it will take me to the documentation in the same page. Okay, so I'll go back, and basically you can go through that. Now the what are activation functions? What other activation functions are there? What is a problem with ReLU? How can we take care of that? What is sequential as such? The model parameters, and then check your knowledge. And then we just can go one step next, and we can say, can we have autograd over there? Can we do the automatic uh, uh, differentiation as such, how to enable it, how to work with it, and way more details, which are very nicely described with these diagrams over here and so on and so forth. So this is the next step which you can take, uh, and definitely save it, save the models, save it as part of the machine learning lifecycle, uh, and then further we can say use it in, maybe pull it later on into another location, and then deploy it and start doing the inferencing with it. So all of those details are there. And in the next session, we will be going through the PyTorch, but with computer vision. And the session is next week, and we will be creating. We'll be seeing a lot of things, but we will be working with convolutional neural networks also, and they will be very suitable for image data. I'll just go through the questions and then I'll help you with it. Okay,
Hi Shivam, thanks for the session. Hello.
Yes, go ahead.
Yeah, this is Suraj. Okay. As a part of the ML service in Azure, I mean, what is the service that you're providing? Is it just the VM, or are there some other libraries that help us to integrate the models that we have into the system, or and also is the system configurable? Because I see there's some 13 GB of data and we didn't have a GPU. So are there various tiers of systems where it's faster to train these models? And also
Absolutely.
regarding the data that we have, right? We might have some non-standard data. Where do we store that?
Okay.
Is it something? Yeah.
Okay. So now what is this service? Like, so the Azure Machine Learning Service is the primary tool for custom AI. Now, this service is having multiple offerings over here. For example, let's say I have uh, terabytes of data. Then where am I going to put it, and how will I get it from there? So there is a particular thing in Azure, or basically we have the HDFS compatible or HDFS equivalent data lakes, for example, and we have no limits on this. So any amount of data might be there in a data lake. But where is this data lake? This has to be deployed in your resource in some location in your subscription in some location in the world as such. So you have to create this data lake first. That is the data lake where the data will be coming from something, one system which is maybe left to it, and that system might be ingesting the data in stream mode or maybe ingesting the data within batch mode. Those services can be the ETL ELT type of services which we have as part of the ADF and other type of UZI equivalent in Azure. Okay, so now once I have this location maybe or maybe that location which already exists registered over here, I will also be able to get my data from my structured locations. And once I do that, I will be able to also have something like a designer over there, which I will just maybe click on any existing one first, and we will just go through it. So something like where you can visually also maybe train the models. And I am pretty sure this is pretty self explanatory as such, right? So that's that's another thing. We have the auto ML functionalities where we will be defining the pipelines over there for the auto ML. Now, the model registry. Apart from the model registry, how do you maintain the environment over there? Like, if I have a model, I would like it to be I would like it to be deployed in a manner which can decouple it from the underlying platform. So that is something where we can bring in containers. So how easily can a data scientist define one environment file, model, and a score file. Three things, and just say uh, create the image, and the rest of the Docker or rest of the container commands or container complexities are abstracted from them. They don't have to work with on the Docker level. They will be as productive. They don't have to learn something more. They will be more productive into what they're doing. And then the registration of that, like where are we going to manage it? Do we want Docker Hub to be there, or do we have something in Azure? So we will be using which something which is already in Azure, like a container registry. So that goes in the registries over here like this. So the ML service interface which we are working with will be able to connect with multiple solutions inside Azure to be to help the data scientist in the entire model development lifecycle in storing the versions of the data set. If I go back and click on this, so data sets over here like this. So let's say last month I made version 1, 2, 3, 4. So I want to roll back to the previous one. I would like to see what was different in the version number 2 versus 3 and 4th. We can do all of those things. We will also be able to have the capability of doing the data labeling. If we are getting unlabeled data, I can start one experiment over here. I can start this data labeling project over there. So I can involve my company, let's say Active Directory based users, or even external people, contractors or something. I can create one project, and then they will start. going and doing the labeling, and I will be able to manage and monitor it. And does it provide some sort of GPU based functionalities? So we have the clusters which will be having the GPUs over there, and then based on our need we will be selecting the sizes from this location, like that. So Tesla K80 GPUs as such, the cores and so on and so forth. Now something which so here uh, this GPU, this cluster is a GPU cluster, but it's not Spark based. What happens if I would like to use something like Spark along with it? So we will be able to submit the job without with, you can say, maybe with 1% modification in the existing script. In We just have to go to in one location, say target is the compute cluster, which is again defined as maybe attached compute, so which is simply Databricks, and the job is submitted, and we are abstracted from the abstracted from the complexities of Spark also, and we can be more productive as well. So we can have MapReduce based machine learning models as well. You can even use Kubernetes for deployment as well, for training purposes as well. The serverless Spark pool is also available, which is the serverless offering, the Spark offering as serverless as part of the Synapse analytical pool, and simple VMs also. So the individual VMs like data science VMs and all of those things are possible. Now, interesting things will be that apart from all of these things, which are pretty logical for us to be using in various locations, we will also be able to create the MLOps pipeline using all of them. And we will be able to have heterogeneous compute locations, heterogeneous storage locations in same pipeline. We will be able to have one job in the pipeline which can maybe run overnight in a MapReduce cluster and do my data cleaning. And once my output has been registered in the data set as a latest version, then the next job on top of it, or next script on top of it, will may further maybe using maybe the same cluster, maybe another cluster, and the ease of use or the integration is pretty smooth over here. So, and best thing, bring your own libraries. There is no limitation of any type. There is no vendor lock-in problem. Any library which we can think of, we can get it and we can work with it. Okay, so that was a long answer for that, but let me just go through a couple of more questions. Okay, so how do we define how many epochs we need to run? Now, the so epochs will basically means that the pass will happen on the entire data as such, like the data is getting passed multiple times. Now, these are hyperparameters, and it will also depend on uh, whether in the you will be able to understand whether your model is performing or not after a couple of initial epochs itself. Uh, if it is not performing, you may not would like to go ahead with it. So this is something which is like a hyperparameter, which, and it also depends on my budget as well of CPU or GPU.
So in this case, Shivam, like for example, I'm using a different open source like collab, and I'm using for large data sets, I'm using GPU, which is inbuilt GPU, right? So in that case, for example, I've run 10 epochs, and each epochs are giving me different accuracy of test accuracy. Okay, maybe. So in that case, how I'll define that I have to run 10 accuracy, or I have to run 50 epochs or 70 epochs?
Now, see, okay, let's say you have defined 70 epochs or anything as such, the
Yeah.
number which comes into mind. First of
Right.
all, hyperparameters. Secondly, the uh, for example, let's say I started the 70 over there, but I noticed, or we are supposed to notice that uh, after the couple of iterations, is it what is happening with the loss? Is it coming down? Is the accuracy going up or not? If not, you may would like to early terminate the epoch as well. And
So
yeah,
okay, sorry to interrupt, Shivam. Like, For example, I've taken 10 epochs, okay, and I started the run the command, and in my first epoch, I see accuracy is like 0.87 percentage, and my second epoch, I can see the deviation from it's increased from 0.89, and again in the third epoch, I can see that 0.88 percentage. So how in that case, I'll make sure that I whether I have to run 10 epochs or 50 epochs.
See, hyperparameters. The problem with
Mhm.
hyperparameters are that we have to try and see it. For
Okay.
example, we have two type of parameters like model parameters, which we can define as part of the algorithm, and hyperparameters, which we have to try and see like the various iterations and possibilities. So if you see that your algorithm, let's say your accuracy is starting from a very good number and it increasing, you would like to try more variations over there. uh, it just by We will not be able to just blindly define that, okay, after 20 I will be getting the maximum result out of it. It's a hyperparameter. Try it out. You may have to try various combinations. At that point, you will not be able to define that.
Right. I got it. So since here in this, in your case, you use PyTorch. So if I use like, TensorFlow or Keras, so it will have different accuracy, right? So I will write out
Syntax
depending
will
on
be
my
different.
requirement. Yeah.
Syntax will be
Okay,
different.
Steven. Yeah, thank you, man. Yeah, thanks.
Right? Okay. Okay. There is one question which says that the Azure ML ingestion training tests present in the external sources like Amazon and Google can be imported, right? Yeah. So you can do it like this. If I click on this data set and if I click on create from web files over there. So you have to get the S3's the files URL as such. If you have the FQDN, we can pull it from there. But this, if we use this, then that source is more or less publicly available. If you would like to do it in maybe if you have, let's say, multi-cloud deployments and you have some sort of maybe a network between your multi-clouds as well, then we have other approaches as well in which we will be get running some ELT job to get it from there. But everything is available or possible. This is your direct way in which you can do it. Okay.
So Shivam, there is available APIs also available, right, for Google and Amazon, where we can call the APIs and we can run in our own code.
But that you have to run it over here inside your code as such.
Correct.
Now
Correct.
there
Yeah.
is one problem which may you may come across is that we, if I just write something over here, is that let's say there is we have, let's say, network available. This is network. It's inside the network. We have done some sort of private link
So, for example,
integration.
take a real-time scenario. I want to get a data from Twitter, and I'm calling an API from Twitter. Okay,
Correct.
in my collab or any local code you're using. So, in that case, what is the drawback or cons? Like,
Okay. So now the tug of war is always between how secure we are and how much flexibility do we want. That can I get the API call done directly in my training cluster, which is inside my company's environment, and then we are get doing the API calls and getting the data from from that location. It's like publicly exposed or not. So
yeah,
most probably you will not be able to do so easily in your real environment because the network restrictions will make sure that the
correct.
that we are secure
So
first.
we are not taking Twitter, Shivam. We'll take a Salesforce. For example, I'm working on Salesforce environment. I have to use Salesforce APIs to track all my objects, okay, and all the details of my Salesforce information. In that case, what is the cons?
Two things you have to do. So we
Yeah,
have one concept called as HPC, Azure batches.
right.
These are
Correct,
HPC.
correct. Yes, that's
So
right.
we literally, you can say you can run these HPC cluster and you can have any practical job running over there. Now, the purpose of them is to get your data on a very high throughput, doing parallel API calls. And if the other system supports it, that you will be making sure it does. And then once it gets it, any type of transformation, protocol conversion can be done over here. These are parallel jobs. Now, once you have your data, you have to throw it somewhere. So let's say this is my data. I got that in maybe some location. And then on the right side of that is somewhere is the data scientist creating his models with it. Second thing is We can also use Azure functions. Azure functions are going to be, you can say, working in serverless manner. The problem will be that they are serverless. So if your job is long running, then they are not the most appropriate cost saving mechanism. But you can do that. We have the capability of having function apps running inside the app services, which will make sure that things are still working. So these things are there, and there can be more. Data Factory can also do API calls and so on and so forth. But you have to have that ingestion layer first. And if you're streaming the data, if you're getting the stream from somewhere, put one event hub, catch your stream. Event hub is the broker. Get it, put it somewhere, then do uh, the ML part of it. Or if you want to work with the real stream itself, then that stream should directly go in the Spark cluster. And the way we saw that we can have attached compute, the job will be submitted to that attached compute, and that is where the real-time stream analytics is going on. That will be pretty accurate to work with, and you can do your real-time, uh, maybe maybe if it was some sort of click stream coming from e-commerce website, then real-time recommendations are going back, and we are dynamically changing the price of the uh, products based on the of the, you can say, that the searches which the people are doing. So those things needs to be done.
So in that case, how we can securing the data of each customers? For example, if you're getting the data from Salesforce API for any customers, and in that case, how we are encrypting the patient's information? Sorry, not patients, the customer informations.
Okay, now we
Because I
have
believe go ahead. Yeah.
it. So see, now once you get your data, the data lake Gen 1 which we had earlier had the capability of encrypting the data uh, literally as files over there. Gen 2 doesn't have that inbuilt. I think they're working on it, maybe out, maybe I'm not aware of it. But
Correct.
Gen 2
Yeah.
doesn't have that exact functionality. So what we do, we generally run some jobs doing that over here. So it will encrypt the data. Second problem is, what happened if my customer uh, clicks on the you have provided him the capability or the functionality that they can say that delete my data. This is my personal data, like we have in YouTube or we have in other social media platform, like delete my personal data. Then if they click on that, then we basically have to delete, we have to have some mechanism to delete the data. And if you are working with some sort of maybe a data lake type of solution where you have so many files in Parquet file, then just imagine how difficult that is. So we have, luckily we have Delta Lakes. We may have to think about some vacuum commands over there to delete those data, or these are the possible things which we may have to think through.
So can we mask the data? Like, we need only specific information, like only the email ID and the phone number, rather than all the information of SSN number or other details. Can we do mask the data in that case?
We in
From Azure?
ADLS
Mhm.
in ADLS, I won't be able to do that. I really have to run the some job to do it over there. But imagine I had the warehouse, a dedicated SQL pool, or maybe Azure SQL. We have masking functions, which are just click-based masking functions. They have the capability of doing data discovery as well. Like they will find me what data was supposed to be masked, and I forgot to mask it, and it is masked. Then we will be masking it, or it will help us out in understanding that which column should be you can say protected, column level security, row level security, and so on and so forth. Azure Purview is another example which will help us out into understanding that okay, which data was lying where, and what is supposed to be done on top of it. So we have n number of solutions available for that.
Thank you, Shivam, and sorry for anybody have taken my time. Yeah, sorry. Thank you.
Right. Okay. So guys, I think I'll do one thing. I'll just put my LinkedIn profile in the chat window, and we can have the questions there.
I already requested you for the LinkedIn request, Shivam. Yeah,
Thank you.
yeah. Thanks, everyone. I have to drop for another call. Thank you.
So I believe we don't have any more questions, so we can wrap up, Shivam.
Yeah.
Just one last
Sorry.
question. What are the further sessions that we have after this? I mean, will be focused more on PyTorch on the Azure ML service part?
We have upcoming sessions on
Yeah.
we have upcoming sessions on both. We are actually exploring many more things like uh, Azure ML provides the capabilities to create, you can say, pipelines and rest of it. But we would also have to use the frameworks and the distributed frameworks to be able to do that over there. So we have these sessions which are lined up on all the capabilities. Like we have one of the couple of sessions on TensorFlow, what we did today, but with TensorFlow. We have a couple of more sessions with which doesn't go into any TensorFlow or PyTorch. Will just specifically will be just doing some pick up some data set and do some analysis on the data set, have a look at it, and train it for some particular specific things. So and MLOps sessions are also coming up. So all of them are in the Reactor group. If we join the Reactor group, then and just scroll for the upcoming sessions, you'll find a huge list of interesting sessions which Rashmita has put till April, I think. So have a look at that.
It's already there on our Reactor Microsoft meetup page, so you can find all the session details there.
Okay. Thank you, Shivam. Thanks.
Yeah. So, yeah. Thank you, Shivam, so much for the session, and thank you all for joining us today. Please do share your feedback about today's session, and also please feel free to use the Learn module link shared in the chat section. Also, please visit our Microsoft Reactor Bengaluru meetup page for more upcoming session. Thank you all once again, and enjoy the rest of your day.
Thank you. Thanks, everyone.